Welcome back. In this part of the series, we want to discuss redox and electron transfer. This is going to be another definition of oxidation and reduction. Remember, in the previous class, we defined oxidation as gain of oxygen, and we defined reduction as loss of oxygen. We used the reaction between magnesium and oxygen to give us magnesium oxide as our example. We want to use that same reaction to define oxidation in another way. Before we look at that definition, let us look at this illustration to look at what happened whenever magnesium and oxygen combine. So this one will bring us back to our knowledge of ionic bonding. Remember that magnesium is the element number 12 in the periodic table, so it means its electron configuration is going to be 2, 8, 2, and then we can show that here the first shell has 2 electrons, the shell in the middle has 8 electrons, the last shell has 2 electrons. So we're going to do the same thing for oxygen as well. Remember again that oxygen is the element number 8 in the periodic table, and its electron configuration is going to be 2, 6. And if you want to show that here, it means the shell number 1 has 2 electrons, and then the next shell has the remaining 6 electrons. So we can 1, 2, 3, 4, 5, and 6. So this is electron configuration for magnesium and that of oxygen. In our knowledge of ionic bonding, magnesium has two electrons at the last shell, so these 2 electrons, and oxygen needs 2 more electrons to be octet. So it means for magnesium to be stable, just like group 8 element that is very close to magnesium, which is neon, and for oxygen as well to be stable, just like the group 8 element that is very close to oxygen, which is neon as well, both of them have to exchange their electrons, their valence electrons. So it means magnesium can lose this valence electron to oxygen, and if you add this electron to oxygen, so oxygen is going to be, it will have 2 and then 8 electrons, and then magnesium will have 2 and 8 electrons as well. Let's show that the transfer of electron from magnesium atom to oxygen atom. Let's use our arrow to show that. So magnesium will lose this electron to oxygen here, and then it will lose the second electron to the other electron of oxygen here as well. So eventually we are going to have magnesium oxide like this. So the 2 electrons gained by oxygen, so we put them here, that gained by oxygen from magnesium, and then remember the last shell of magnesium, the last shell here, contains the 2 electrons. So since magnesium has lost those 2 electrons, so we don't need to put that last shell there again, remember. So to show that it is magnesium ion, because magnesium has lost 2 electrons, the electron configuration is going to be 2, 8. So, and then we'll put this bracket here. It has lost 2 electrons, so we have 2 plus here, and then we have to put the bracket. Remember, we did all this under ionic bonding. This is magnesium ion, Mg2 plus, and then we do the same thing for oxygen. So this is oxide ion, O2 minus. The electron configuration for this is going to be 2, 8, and then we'll put 2 minus here. So what happened here is that magnesium transfers electrons to oxygen to become magnesium oxide, and then oxygen gains electrons from magnesium to also become magnesium oxide. That is where the definition comes. Anytime a substance loses electrons during a reaction, that substance has been oxidized. Before magnesium can gain oxygen and become magnesium oxide, it sacrifices 2 electrons. So loss of electrons to become magnesium oxide is oxidation, just like gain of oxygen last time. So we can put it together and say if a substance loses electrons in a reaction, the substance has been oxidized. So magnesium loses electrons in this reaction, so magnesium has been oxidized. And if a substance gains electrons in a reaction, the substance has been reduced. So oxygen gains electrons from magnesium, oxygen has been reduced. If you go back to our previous definition, if a substance gains oxygen, you can see that substance has been oxidized. If a substance loses oxygen, that substance has been reduced. So in terms of electron transfer now, getting of electron is reduction, losing of electron is oxidation. And because losing and gaining of electron is taking place in that reaction, so that reaction is nothing but a redox reaction. It is not easy to show the transfer of electron in a redox reaction using the arrow that we use here. So it's not easy to do that. So instead, we can use what we call half equations to show the electron transfer in the redox reaction. Half equation means one half of the equation shows electron loss and the other half will show electron gain. So we're still going to use the same reaction that we used up there, reaction between magnesium and oxygen. Remember we said magnesium loses electrons to oxygen to become magnesium oxide. So if you want to use half equation to show this process, we write down the reactant, that is we write down magnesium with that process of losing electron. I'm going to do the same thing for oxygen as well. So let's start with magnesium. So this is our magnesium side. Magnesium is Mg and then this is the arrow. So we are writing magnesium half of the equation. That is this part. This is magnesium half of the equation and this is the oxygen half of the equation. So let's write the half equation for the magnesium half of the equation. So magnesium at the reactant side here, so it becomes magnesium ion Mg2+. Remember in ionic bonding, the magnesium ion with its Mg2+, we saw it up there, so combine with O2- with its oxygen ion to become magnesium oxide. So they are held together by the electrostatic attraction. So we only take the magnesium part of that magnesium oxide, but we cannot stop here because this we've not shown the movement of electrons. This magnesium here becomes magnesium oxide here. How? Because it loses electrons. So that electron that is lost, we have to show it. So magnesium loses how many electrons? 2 electrons. So this minus means it loses 2 electrons. So if you write it this way, it is fine. But IGCSE, they want the electron lost to be at the right side of the equation. So you move this above this arrow and you put it at the other side here. So because it jumps over the arrow, the sign has to change. Remember, just like in mathematics, when you have 2 minus x equals 5, so it can be 2 equals 5 plus x. So the same thing here. So this is the magnesium half of the equation. Remember, this is oxidation because magnesium loses electron. So let's write for the oxygen half of the equation. Remember, oxygen gains electron. We write oxygen atom. Let's use just only one oxygen atom, O, instead of O2 to make it easy. So we have O now, and then it gains 2 electrons. If you remember, up here, one oxygen atom gains 2 electrons from magnesium. So we're going to do the same thing here. So this is our oxygen atom, and then it gains how many electrons? 2 electrons. And it is also very easy because up here we can easily see that magnesium loses 2 electrons. That electron that is lost by magnesium is what oxygen gains here. Oxygen gains 2 electrons to become oxide ion, O2 minus. If you go back up here, you will see that we have, this is our O, and this is our 2 minus. So we're just writing the same thing. The one on top here is that is this first equation here. This is the magnesium half of the equation, and this is the oxygen half of the equation. We are not done yet, but if you write this one in the exam, you are still fine, but we need to let it look exactly like what we have up here, because we have 2 atoms of oxygen, but here we have only 1 atom of oxygen. So we only need to write this one again. So I will copy this, then I will paste this under it. So I will combine it together very soon. So we have oxygen and another oxygen atom. So that one will give you O2. So O2. So it looks like the oxygen that we have up here with this oxygen molecule. And then plus how many electrons here now? 2 electrons plus 2 electrons becomes 4 electrons. It is where students get confused. So you cannot write O4 minus. This is completely wrong, because it's not possible for 1 oxygen atom to gain 4 electrons. 1 oxygen atom can only gain 2 electrons. So how do we reconcile that here? You just write your O2 minus here. But how many of them do we have up here? We have 2 of them here. So I can move this one backward like this, and then I put 2 in front of it here, showing us that we have 2 oxide ions. We have the magnesium part of the equation and the oxygen part of the equation. So we can combine the 2 equations now. Let me take the magnesium part of the equation, which is Mg. I'll write Mg. Let me just carry it from here, so make it easy. So we have this, and then we paste it down here. So this is the magnesium part of the equation, and then let's take the oxygen part of the equation, and then we'll put it down here. Yeah, if you stop here, there is something wrong, and then you should have seen it. If you look at here, oxygen gains 4 electrons. However, magnesium loses 2 electrons. So we must reconcile the 2 electrons. The electron lost must equal to the electrons gained. So how do we do that? Just like in your simultaneous equation in mathematics, just multiply everything up here by 2. So when we do that, electron lost by magnesium will be 2, and then it will equal to the electron gains by oxygen. So I'll copy this, and then I'll put it down here, and then I put the balanced equation. So this will be 2 magnesium atom. It's going to be 2 magnesium ion, and instead of having 2 electrons here, it becomes 4 electrons. So if we check now, sorry, I think there's something wrong. That's not the one I'm supposed to delete. So 2 magnesium atom, and this is going to be 4 electrons that is lost. So you can see that we have 4 electrons gained by oxygen and 4 electrons lost by magnesium. The equation is well balanced that way. So if you like, you can combine the 2 equations if you like. So if you combine the 2 equations, we are going to get what we have up there last time. 2 Mg plus O2. So these 4 electrons, we don't need it, and then because it is 4 electrons, yes, both of them, they cancel each other, and then eventually we are going to have 2 Mg plus O2 to give us 2 Mg2 plus, and 2 O2 minus. So if you put them together, just like in mathematics when you have 2x times 2y, same thing as 2 into xy. So we can do the same thing here. So I will erase these 2 and these 2. I will erase them, bring this close to this. So let me write this clearly. This is 2 plus and 2 minus. They can cancel each other. So this one we cancel this. So bring them closer again. So the 2 that I delete, which is common to both of them, we just put it out here. So you can see that we have that equation that we have up here that we started with. You can see what is the equation. This equation, we have it back down here. But when we combine the two half equation, we have a single full equation. So that is how to define redox reaction in terms of electron transfer, and how to use half equation to show electron transfer in a redox reaction. And it's going to be the end of this part of the video. So in the next class, we will look at redox without oxygen, because if you look at all our examples here, we are still using oxygen. So in the next class, we are going to write redox reaction without oxygen at all. Thank you so much, and see you in the next class.